All right. Lab rats, backyard physics. Okay, there's been a little bit of confusion on what to put on your write-up. All right, because I'm getting people wanting, and I've been wondering for like 3 semesters why students have been putting centimeters when we spent all this time learning the reaction time, which might be a little bit different than the actual distance that it fell. Even though you might get an accurate data that way, the purpose of this was to take something that we could measure pretty easily, pretty accurately, by dropping the ruler thing, to getting something that would be really hard to measure with a stopwatch, which is do the time. So you're going to use this equation where you're going to take your data of the height, like say somebody, it was 26, say y1 is equal to 26 centimeters, then what you need to do with that is take 2, get the time. It would be take the square root of 2 times 0.26. You'll have to convert it to meters, divided by 9.8 meters per second squared. And look what happens. The meters cancel, the seconds come up here, and they cancel, or the squared goes away. And so in this case, if I can find my calculator, which I don't have handy, of course I don't. Here we go. Fibber McGee's closet going on behind me. So we'd do this. We'd take 2 times 0.26 divided by 9.8. It's equal to a really small number there, and then divided by, and then take the square root of it. And I've got 0.23 seconds. So for that one is 0.23 seconds. And that's what I put in over here on, this is your data. I want your data to be in the time. Okay, so in other words, you're going to, each one, you're going to do the time is equal to 2 times the distance it fell in meters, like 0.25 meters. This is an example. All right, this is strictly an example. And then divided by the 9.8 meters per second squared. And then this would be t squared. And then get that number and then take the square root of it. And you'll get the time. And those are what, this would be T1, T2, T3. Those are the things you put in here for your 2 sets of data. All right? Okay? And then you go to this, and what I would say to use is use it for 2 independent means, t-test for 2 independent means. All right? And not dependent, t-test for 2 independent, because these are 2 independent things. And when you run your t-test, if you get a number that is p less than or equal to 0.10, then you reject the null. Now your null hypothesis reads like this. Reject the null. In science and psychology and things like that, the null hypothesis is this. There will be no difference in the reaction time between group 1 and group 2. And then you define group 1 and group 2. You know, like, you know, left-handed, right-handed, men, women, kids, adults. Groups 1 and 2. Okay? Then define those guys. All right? That's the way you do it. Because the null hypothesis means there's no difference, and if this comes out to be less than, then there is a statistically significant difference between the 2 groups. Okay? Clear as mud? If not, please call me tomorrow. I've got to take my wife to go get the stitches taken out after her surgery on her shoulder here. She's a trooper though. And if you're still unclear, email me or call me tomorrow morning after 10. I'll be in the office because I teach from 8:30 to about 9:45 tomorrow. All right. I think you guys are doing great. I love the questions I'm getting. And you know what? Don't feel like, well, I didn't understand what you were saying. Right. I didn't tell you to do that. I just noticed this on this data table. When you do your own investigation, when you're supposed to put in these results, I don't say anything at all about that I wanted you to put the time in there. I kind of just implied it. That's not good. That's not a good thing. All right. So there we go. All right. Out here,